More educators are learning of the vast cognitive functions of the brain and planning their lessons according to these to have a more applicable and efficient learning process for students. Several examples of these functions are working memory, attention, mental flexibility, self-regulation, planning, inhibition, and organization. One of the most important cognitive skills for students is working memory due to its role in improving their achievement in school. Working memory is a subcomponent of an overarching cognitive skill of memory alongside other components of short-term memory, sensory memory, and long-term memory. It is briefly known as the small amount of information that can be held in mind and used in the execution of cognitive tasks. Working memory is employed in concept formation, control processes, mnemonic strategies, sentence recalling, spatial, verbal, and arithmetic domains, which shows it is an important component to ensure the efficiency of students' learning process. As working memory is acknowledged as an important component in learning, there is an emergence of multiple interventions devised and utilized for specific settings. There are three main types of methodologies practiced by children aged 4 until 11 years old in the classroom. They consist of environment adaptation, direct working memory training with or without training instruction, and indirect training skills such as phonological awareness and physical activity. In addition to the above mentioned, there are also computerized interventions of working memory. Educators' objectives for the students remain the same, which is to produce near transfer effects, far transfer effects, and generalization, which can be achieved by different interventions. Nevertheless, there are several obstacles that might surface in their implementation. Educators are required to address attention first prior working memory to properly conduct classroom working memory interventions, whereas heterogeneity is evidently present in conducting computerized working memory interventions, leading to indefinite inferences. Thus, the current research is proposing another methodology, which is the utilization of binaural auditory beats in modulating working memory. Several past studies have been conducted to observe individuals' cognitive function of memory, such as working memory and long-term memory. These studies were conducted in samples of populations from different countries, such as Spain, United States of America, the Netherlands, and Germany, whereby the common age range of participants were from 18 to 40 years old. According to these studies, there is still yet an opportunity to observe the modulation effects of binaural auditory beats towards working memory abilities of the Malaysian population, specifically young adults. Most Malaysian young adults embark on tertiary education of their choice after completing secondary education, while pursuing other activities such as having a career, honing life skills, and networking, in which exert an excessive demand to the working memory function. The aim of this study is to investigate the effects of alpha binaural auditory beats on working memory of young adults using the automated operation span task. According to a study, participants who consisted of young adults showed better working memory performance after a neurofeedback training that specifically improves upper alpha frequency band. Additionally, another study observed that alpha brainwaves can be increased by decreasing beta brainwaves, in which this process produced an improved state of memory. Based on the above mentioned, these studies have provided explanation that alpha brainwaves can be trained and increased to better the specific cognitive domain. Furthermore, it is also of interest to investigate the possibility of the auditory beat stimulation in education and working environment, as there is still opportunity in applying this technology in real-life situations which can directly benefit the community.
Working memory. The brain's working memory refers to the human memory system which temporarily maintains, stores, or manipulates information for cognitive tasks such as learning and reasoning. Working memory is a limited capacity system because it can only keep a limited amount of information in a short period of time. Working memory is different from short-term memory because short-term memory typically refers to remembering information for a short time, usually in a few seconds. For example, people's name or phone numbers will be forgotten if it is not being rehearsed. The same goes for when we are remembering the route to a certain direction. Thus, the process of repeating the information and carrying out the task relies on our working memory. There is a close relationship between working memory and long-term memory. Long-term memory refers to our childhood memories or the knowledge that we have acquired and remembered over the years. For example, the facts about the country, family history, or mathematical knowledge and grammar rules. Next, working memory is important for various complex tasks such as reading comprehension, mental arithmetic, and word problems to basic tasks such as copying notes in the class. A variety of strategies or training could help to improve the working memory capacity, which might help individuals to perform at their best. Now, let's move on to the binaural beats on working memory. There are several studies that have shown the relationship between the binaural beats and the memory. First, binaural beats are described as an auditory perceptions that are presented separately on the left and right ear by the two tones of slightly different frequencies. A study by Cross and Parabanova has shown that the brain activity changes automatically if the binaural beats match the frequency that corresponds to the alpha wave spectrum. Next, binaural beats could also affect various aspects of cognition or mood states for an individual such as attention, memory, creativity, and alertness. Besides, it is also an efficient way of increasing long-term memory in order to retrieve, identify, and enhance the encoding of new data. There are several factors that affect the binaural beats on cognitive functions, such as the specific frequency of the binaural beats, the targeted population, and the methods used to detect the possible improvements in working memory ability. The target group is important because the level of brainwaves activity in older people is different from young people. Moreover, binaural beats may have a beneficial impact on retention, attention control, as well as the storage and the activation of information. Thus, it is shown that binaural beats have a relationship on working memory.
Next is binaural beats versus non-binaural beats. The usage of binaural beats allows different regions of the brain to be activated significantly by disparate simulations of sound frequency detected in binaural beats. There is a high possibility in boosting cortical synchronization aside from stimulation in the hemisphere, which leads to improved brain processes. Furthermore, it is said that application of binaural beats improves cognitive processes, provides sensations such as relaxation, altered conscious states such as producing lucid dream, as well as improving one's creativity. Non-binaural beats, on the other hand, includes vocal melodies or musical beats that are translated into sound waves and assisted by lyrical melodies that synchronize with the musical sound waves. Different voices of different pitch have significant advantage in memory enhancing. The influence of vocalization reflects a higher rate of arousal, where female pitch has higher memory influence compared to male due to emotional influences. In contrast to vocal melodies, binaural beats does not incur female and male pitch influences on human emotions. Instead, it influences different brain area activation according to the low level of sound waves. Hence, studies on the binaural beats enable studies of sound wave on memory without the interference of other variables. According to Bedley and H in 1974, working memory holds information temporarily in the mind, enabling us to perform a variety of cognitive-based tasks. To assess working memory, complex working memory span or operation span tests can be applied, as this method requires individuals to remember a set of details in the correct arrangement with the interceding of secondary processing tasks such as completing equations. The O-span task is notified as a task to predict intelligence, as it involves the process of information manipulation and memorizing in problem solving. Working memory span tasks usually involves a simple span task around 3 to 5 items and having an average of 5 to 9 items maximum for complex span memory tasks. It applies mnemonic strategies such as information chunking processes, which enables tested individuals to group stimuli together in smaller independent units, which is easier for the brain to capture or memorize. This results in the suggestion of simple span tasks in measuring working memory, as it is dedicated to item memorization and is rather a passive process. Next is automated operation span tasks. In this study, we incorporated automated complex span tasks which can be used to test more rapidly in a computed manner, allowing the result to be produced instantly. The trials created by the span tasks are randomly generated, ensuring that there are no bias in the test in case the test subject tries to memorize for the upcoming replicates or even to memorize due to repeated tests. The results from the test will depict individuals' task processing, feedback processing, as well as storage accuracy. All of the test subjects will be asked to solve mathematical questions, and then they will be shown a letter to be recalled at the end of the test. This will be going on for around 3 to 7 letters to be recalled. The final result of the test will show 5 distinct scores, which are the absolute storage score, processing error, partial storage score, speed error, and accuracy scores.
A total of 5 young adults aged between 25 to 29 years old were chosen as participants through convenient sampling method. All participants are working adults and are healthy in terms of hearing ability. None of the participants have any hearing deficiency, needing hearing aids, or having tinnitus, which, as described by Agamon and Roberts, is an auditory phantom sensation, or in another word, ringing in the ears, which is felt when there is no external sound present. The participant also indicated that they do not suffer from disorders such as epilepsy or attention deficit hyperactivity disorder, also known as ADHD. The operation span task is used to measure working memory capacity, and in 2005, a computer-administered automated operation span task which works automatically was developed. In the operation span task, participants solved mathematical operations and remembered the presented letters after. These tasks were repeated for 3 to 7 times. Next, the participants were asked to recall back the presented letters in order. Next, the participants were presented with feedback that shows the success of the task, showing how many letters the participants able to recall correctly. In the automated operation span task result, the first score, which is the Ospan absolute score, shows the total of all correctly recalled set of letters in the correct order. This score were used in the analysis. It is stable in terms of test-retest reliability when repeating the test after a few minutes, weeks, or months. Binaural beats is a subjective auditory sensation when two tones with slight difference in frequency are presented to each ear separately. Hearing to binaural beats, listener will hear a resultant sound with an amplitude which change with a frequency equal to the frequency differences of presented tones. When perceiving two tones with subtle differences between them, the brain will pick up the difference between the two frequencies and the brain will hear this difference as a binaural beat. Software called Audacity was used to produce two tones, which are 200 and 210 Hz. The difference in these two frequencies is 10 Hz, which falls in the alpha frequency range. Two types of recording were used in this study. The first recording is the sound of the sea overlapped with binaural beats, while the second recording is the sound of the sea without binaural beats. Day 1, the participants were asked to take the automated operation span task. After the completion of the task, the participants were given to listen to recording with binaural beats for 10 minutes. After the 10 minutes, the participants were asked to retake the automated operation span task. Day 2, the process is the same as day 1. However, after the completion of the first automated operation span task, the participants were given to listen to recording without binaural beats for 10 minutes. After that, the participants were asked to retake the automated operation span task.
This is our findings for the result of the study. Table 1 shows the result for the OSPAN absolute score obtained by 5 participants, which consists of 1 male and 4 females. The score shows the participants' total of all correctly recalled sets of letters in the order in the OSPAN task. As we mentioned earlier, this study took 2 days for the participants to complete the task given to them. For the first day, the participants need to listen to the 10 minutes recording of the ocean wave with binaural beats after completing the first task and before proceeding to the second task. The findings for the first day of the OSPAN task have shown an improvement from the first task to the second task for participants 2, 3, and 4. As we can see here, for example, for participant 2, the score for the first task is 49 and the score for the second task is 57. However, participant 1 and 5 shows a decrease for the absolute score from the first task to the second task. For example, participant 1, the first task is 47 and the second task is 42. Next, for the second day, the participants will have to repeat the same process, but they will listen to the recording of the ocean wave without binaural beats. Based on the table shown, the absolute score decreased for all participants except for participant 5, which shows no changes for the first and second tasks. The score maintained at 68 on both tasks.
The objective of this research was to observe the effects of alpha binaural auditory beats on working memory of young adults using the automated operation span task. It was hypothesized that there would be an improvement of performance in the working memory task after the implementation of binaural auditory beats. Based on the results, the majority of participants showed improvement in the task performance as observed in the score increment after the implementation of alpha binaural auditory beats for 10 minutes. Similarly, this type of observation was observed from a research which effectively modulated visual-spatial working memory. Based on studies which recorded and analyzed brainwave oscillations using neuromodalities such as MEEG and EEG, the authors have found that alpha wave oscillation was present in tasks which measures a working memory function. Based on this established phenomenon, it provides a basis to the current study in benefiting from the application of alpha binaural beats to improve the above-mentioned cognitive function. Nevertheless, the findings showed several participants' performance decreased after listening to the audio stimulus. This might be due to the presence of ocean waves audio embedded with the binaural beat stimulus, in which the former was more amplified than the latter due to the consideration of participants' comfort in listening to the stimulus. Ocean waves, which is classified as a naturalistic sound, may be more significantly perceived by the participants, which affects their psychological state. This type of sound is known to modify a person's psychological state in inducing relaxation and promote more mind wandering. This might also explain the findings of participants' performance in the memory task after listening to only ocean waves without the alpha binaural auditory beats embedded, which was applied in the second condition. This showed that an individual's cognitive function of working memory may be variably influenced by different types of audio stimulation, whereby its characteristics should be carefully considered to positively affect their level of performance. This was supported by a study which suggested further investigation of binaural auditory beats features is compulsory prior to cementing this modality as an entrainment technique.
Many limitations exist in this study, beginning with the very small number of participants due to limitation in obtaining larger samples. Out of 5 participants, only 3 showed an increase in their working memory capacity, which does support the hypothesis that exposure to alpha binaural beats enhance working memory capacity. However, the result is not conclusive enough due to the small sample size. Thus, in future research, a bigger sample size is needed to ensure that there is no error where the results confirm the hypothesis on which the study was based, when in fact an alternative hypothesis is true. This study also lacks EEG measures to further confirm that presenting alpha frequency binaural beats could have induced the brain to synchronize their electroencephalographic waves in alpha frequency. Hence, it is suggested for future study to include data from EEG to further support the result. In this study, only one stimulus is used to test working memory capacity, which is visual stimulus. Future study on this topic could include more than one stimulus, such as both visual and auditory stimuli. Additionally, gender also is the limitation to this study due to the imbalance between the number of female and male participants, where there are 4 females and only 1 male. This is a variable that needs to be considered in future studies, as past research done by Tobias in 1965 found that the perception of binaural beats is different depending on gender, where men perceive a higher frequency binaural beats compared to women. Further research on binaural beats and memory also could include both children and adults as participants to see if the binaural beat has different effect on these two groups. Research on binaural beat effects on memory until now focused primarily on the effect it has during the retrieval process. Yet, very little is learned on the binaural beat effect during the encoding phase. Further research is required in order to assess the degree to which both encoding and retrieval of information result in an increase in memory, which can be done by evaluating the outcome differences in memory tasks when participants are subjected to binaural beats during both encoding and retrieval phase.
With the completion of this study, we managed to reach our research objective as well as answering the research question concerning the role of binaural beats on working memory capacity. However, due to our limited number of samples in the small-scale study, the results might be inconclusive, hence requiring a more extensive study in the future. Through this study, we were able to depict the improvements of working memory capacity as a consequence of alpha-range binaural beat stimulation that was able to be visualized, in which the result supports that alpha binaural beats are able to enhance memory. This can be seen through the result where performance of sample increased after being exposed to binaural beats compared to non-binaural beats. Furthermore, with the results of this study, we were able to contribute to the number of existing studies on the effects of binaural beats, which is low, as well as further support the theory that binaural beats do improve memory. Lastly, the application of this study increases the chance to enhance and maintain greater cognitive performance by implementing binaural beats into a daily regimen, such as during yoga, meditation, and exercise, as well as using binaural beats in the environment of working and studying to enhance performance. Before we wrap up our study, we would like to give our special thanks to everyone involved in the process of idea pitching, especially Associate Professor Dr. Aswati Hamza and Mr. Jacob Krause and his peer for allowing us to adopt the methodology from his study into the research project, as well as all our test samples that allowed us to perform this study upon them. Without the help of people around us, we will not be able to complete this study with success. Thank you very much.